A video for 10-8, geometric probability. We're going to use segment and area models to find the probabilities of events. Might be some review if you are a 10th grader. You had prob and stats last year. 9th graders, you may have seen this sometime middle school, but we're going to go over everything kind of again, make sure that we're all on the same page. Probability is just a likelihood. It's saying what's the probability that something's going to happen. So you could find the probability that something could happen or could not happen. Your answer should always be between 0 and 1. So if you know the probability is not going to happen, then it would be 0%. And if you are certain of it, it would be 100%. So most of your answers are going to be written as a fraction, a decimal, or a percent, because it's going to be somewhere on that spectrum between 0 and 1. There's a little formula for it. If you want to find the probability of something happening, you have to know how many ways something can happen, like the bottom of the fraction. How many ways could something happen? And then all we do is say how many ways could what we want to happen. So number of favorable outcomes over number of possible outcomes. I kind of say it this way. What do we want to happen? Divided by how many ways something can happen. All right, so that kind of idea. Probability is just a fraction. So a fraction will be an acceptable answer, so would a decimal, so would a percent. So in geometric probability, points on a segment or in a region of a plane represent outcomes. So you can find geometric probability by finding a couple areas. So we're going to get a total area and then the area that's shaded or the area that we want. So same thing here, we can use number lines. That's one way we could use a geometric setup for a probability problem. We have this red section here of BC. If I want to know the probability that a random point on that line is BC, all I need is the length of BC to go on top and the length of the entire number line from A to D to go on the bottom. I'm just going to divide two fractions, or divide one fraction, divide two values. What do I want over what do I have? What's the total length? Okay. So if you get ones like this, we're saying point K on this line between S and T is chosen at random. So I know I'm gonna land somewhere on the blue line. Okay. I want the probability that K lies on QR. So I want to know if I can land somewhere on here. Okay. Well, the probability that K is on QR is just the length of QR. This is going to be a fraction. The length of QR over the length of ST. And I know a couple things. I know that QR, if you look at how long this segment is, we can subtract the endpoints. The length of this segment is 8 minus 5. The length of the segment on the bottom is 14 minus 2. So again, 8 minus 5 is 3, 14 minus 2 is 10, 12, my bad. So this is going to reduce down to 1/4. So 1/4, there's a 1 out of 4 chance that we land somewhere on that green segment, or there's a 0.25, or there's a 25%. They're all the same exact answer. They're all equally acceptable. They all mean the same thing. So if you have to do a problem like that, subtract your endpoints and see what the fraction simplifies down to. Similar problem here, and then I'm going to have us switch videos for the second piece of paper, for the second piece of the notes. So these are all the number line types of probability problems. This one says this: a commuter train runs every 25 minutes. So every 25 minutes a train leaves. If a commuter arrives at a random time, we want to know what's the probability we'll have to wait at least 10 minutes for the train. So you can get these scenarios here like this, where we have to take a look at a number line again. So the train is leaving at this point at time 0. Okay, the train is gone. It's not going to leave again until 25 minutes later. So what we're trying to look for in here is just time. So this is 5 minutes, this is 10 minutes, this is 15 minutes, this is 20 minutes, so on and so forth. Okay. If I want to see what the probability is that I have to wait at least 10 minutes for the train, I have to figure out where that would be. If I show up here at time 15, this here would be a 10-minute wait. So anything on the blue line that I have highlighted, this would be a less than 10-minute wait. If I show up at time 16, if I show up at time 17, so on and so forth, I'm not going to wait 10 minutes. If I show up at time 20, that's a 5-minute wait. If I show up at time 22, I have a 3-minute wait. So that's not the part I want. The part I want is over here, anywhere right after the train leaves until that 15th minute, because this would be a greater than 10-minute wait. If I show up at time 10, I'm waiting 15 minutes. So I don't know the probability that I'll have to wait at least 10 minutes for the train. So same idea. So for this probability problem here, I can say the probability that we're going to wait at least 10 minutes. I'm going to set that equal to the length of the entire line, which is 25 minus 0, the length of the section of the line I want, which is 15 minus 0. So in this instance, I have a 15 out of 25 chance to wait at least 10 minutes. And for probability, we just have to simplify. So you can go to your calculator at that point, or we can do a reduced fraction. So we could divide both these things by 5, and this is the same as 3/5. So that's an okay answer, or 0.6 is an okay answer, or 60%. There's a 60% chance if you just show up randomly that the train's not leaving for at least 10 more minutes. So that's that's geometric probability on a number line. The next video is going to bring us through geometric probability with area. So go ahead and switch to that next video now. Here's the second part of the video for probability and area. So the first part, looking at the number lines to find areas. Now we're looking at, it'll be kind of like a dartboard type shape. You're going to have an outer shape, and then you're going to have some portion of it shaded on the inside. We want to know what's the probability that I could throw a dart kind of at that shaded part. So with area, we're looking for a shaded area. So really what we're looking for is what's the shaded area over the total area. So if I can figure out how much of the shape is shaded and what the area is of the entire shape, I should be able to find the probability. So we're going to try that here, and then I have an example for you to try. We'll do the last one with all the crazy circles together. So a circle is inscribed in a square. We want to know what the probability is that we hit, if we randomly throw a dart, that we hit one of these 4 corners that I'm highlighting in blue. Okay, I don't have a shape for area formula for this, because this is a shape that's uncommon. We don't have a formula for this type of shape. So what we're going to do to find that area is I need to figure out, well, first, to find the probability, I need to end up getting shaded over total. So I need both of those values. Sometimes, like this one, you won't be able to get the blue area directly, so we're going to do a little trick for that. So I can figure out the total area right now, because it's a square. It's given that it's a square, so it's 6 times 6, or 36. That's the total area, okay? Since the blue is a shape that's not very common, I'm going to use a trick. I'm going to find the unshaded area, because the unshaded area is just this circle here with a radius of 6, okay? With a radius of 3, I'm sorry. With a radius of 3, a diameter of 6. So if that radius there is 3, then what we have here is a circle, this unshaded circle. If I can take this unshaded circle's area and subtract it from the total, which is 36, then I'll be able to figure out the blue area. So the unshaded area is pi times 3 squared, which is 9 pi. So the shaded area is 36, all of it except for 9 pi. It's taking away the white circle in the middle. If I take 36, take that circle away, I'm left with what's blue, what I want. So the shaded area, 36 minus 9 pi, should be about 7.74. Okay, so I'm going to take that 7.74. So the probability is going to be 7.74, what's shaded, over 36, the total, which is about 0.215. That could be your answer, or you could call it 21.5%. So sometimes, and you'll have to try this in just a second, sometimes you need to find the unshaded area to help you find the shaded area. But what we want to get is shaded and total so that we can divide the two. I'm going to have you try this one. There's no circles this time, but you might want to try to do the unshaded area again to help you find the shaded area. So I'm going to click pause on the video. I would do the same, and then when the video resumes, the answer will pop up. So don't click play until you have it solved. See if you can do this all by yourself. Give that a shot right now, then we'll finish up with the last one together. And there you see an answer there in blue. You should have got 50% or 0.5. So the way you would have done that again, taking this triangle area right here with a height of 5 and a base of 5 to get the unshaded area, taking the unshaded area away from the total area, which is 5 times 5 or 25. So this time it ended up being 50% exactly. Okay. Feel free to pause and check my work again. And rewatch the first example to see if there's any questions that you may have. Okay. Last one we'll do here in the last couple of minutes that I have on the video is this archery target. It has 5 colored scoring zones. The total diameter is 122. So the radius of the whole thing is 61. Okay. Then it starts giving you some zones. The radius of the yellow zone is 12.2. That would fit really small in there. Then the width of each of the other zones is also 12.2. So we want to know what's the probability that we hit red, and then we'll do another problem in just a second. So if I want to know the probability of hitting red, that's this zone here. It's like a donut. So if I hit yellow, that's better than hitting red. So I'm looking for this area here. All right, so I'm going to need the total area. I'm going to need that red donut area, and then I can divide the two. So it's kind of a couple steps here, but we're going to do the entire thing. So the total, we'll get that done right now. We found that the radius is 61, so it's just pi times 61 squared for this circular area, this circular dartboard, this archery target. So it's about 11,683.94. You can plug in your calculator to check. After that, we need the red zone. So what we're going to do is, for a second, we're going to pretend that the entire red circle that I shaded in is filled in, because I can figure out this diameter, or this radius, I should say. This radius, if each zone has a width of 12.2 and the yellow already has a radius of 12.2, this should be 24.4. That would be my radius. The reason it's 24.4 is because it's 12.2 twice in a row. Then the blue one, if I went one further, would have a 36.6, and so on and so forth. So I'm going to use that information because I need to take away what I don't want. I want just the donut. So I'm going to take the outer circle minus the inner circle. So if the whole red circle was, if the whole thing was red, if there wasn't a yellow center, so that would be pi times 24.4 squared. All right, I still have to do a little bit of work because I don't want the yellow part, but we'll get that in just a second. So that's going to be 1,869.4304 if you plug that in. Okay, so then I'm going to take away the yellow zone. That's just a circle inside that's pi times, they gave us that that's 12.2 squared. So what I'm doing is I'm taking away this yellow part, and I should be left with just the red donut. So that pi times 12.2 squared is 467.357. Okay, so now I can get that with these two, the red zone is just 1,869.4304 minus 467.357. So when you do that, I know we got a bit of a mess here, but when we do that, we have 1,402.072. Okay, that's going to be our shaded. We already have our total, so we can get our probability here. Probability of the red zone is 1,402.072 divided by the total we got at the beginning, which was the 11,683.94. Doing that, you should get about 0.12, which is about 12%. So that one's kind of ugly, but you can see the point of just finding what we do want, getting rid of what we don't want. So that one may be as tough as one as you'll see as far as a word problem. There's a lot of steps there. The second part I'm not going to have us do, it's just the probability of the yellow zone. So this one, well, we kind of already have it, so I suppose I'll just throw it in there. We already know that this is just the probability. It's going to be the yellow over the total, and we already have the yellow. So if the yellow is here, we have 467.357 over the total again. That's gonna, if you punch that in, that gets you about 4%, 0.04. Okay, so that one's not that much different. So what we looked at here as I wrap up this video is we looked at finding area on a number line. We looked at finding area using area. So for right now, that's what we're going to have you look at. Make sure that the notes make sense. And then for tomorrow, we will just work on the worksheet. So we'll see you tomorrow. Good job.